Section 3.5 is about the point-slope form of the line. Point form can be used to write the equation of a line. And the form listed above is y minus y1 equals m times x minus x1. Let's look at a couple of examples here. Alright, what I want to do first is write the equation of a line with a slope of 3 that passes through this ordered pair right here. Using slope-intercept form, which we already know, is y equals mx plus b. Oops, mx plus b. I would need to know the slope and the y-intercept. I know the slope is 3, so I can say this is y equals 3x plus b, but I don't know the y-intercept. This ordered pair is not the y-intercept because the x-coordinate is not 0. I can use this ordered pair to find the intercept, though, by plugging it in for x and y. This ordered pair, like all ordered pairs, will make this line true. So I can say 5 is the y value. Will have to be equal to 3 times negative 4 plus b, and I can use this to solve for b. So negative 4 times 3 is negative 12. And if I add 12 to both sides, I can get b. So b is 17. Putting these pieces back together, this gives me y equals 3x plus b, which is 17, so plus 17. And I've got the equation of this line. Alright, so I can still use slope-intercept form if I solve for the b value, but I don't already know the b value, so I do need to use that ordered pair to find it. That's one way of writing the equation of this line. The other way is to use this new formula called point-slope form. So let me write that formula down. Y minus y1 equals m times x minus x1. This formula requires a slope and just any point. So the formula is going to be y minus y1 is the y coordinate of your ordered pair. So 5 in this case equals m. M is the slope of your line, so 3 times x minus x1 is the x coordinate of your ordered pair, so negative 4. Okay, so again, just to highlight some things right here, y1 is your 5, x1 is your negative 4, and m is your slope. M is always stood for slope. Okay, and now let's simplify. Y minus 5 equals 3 times, I'm just going to get rid of that double negative right here and say that's 3 times x plus 4. Then we'll go ahead and distribute. So y minus 5 equals 3x plus 12. Then we'll add 5 to both sides to get y by itself. So y equals 3x plus 17. Same answer as I had before. It doesn't matter how I want to set it up. The only differences are in that if I use point-slope form, it's an equation all along. That's actually the only purpose of this form is to build an equation, whereas slope-intercept form gets used for lots of things. I can use it to write an equation by solving for b and then plugging it back in, or I can use it for tons of other things. So sometimes when I'm trying to remember how to write the equation of a line, it's convenient to have a form that's just for that. Okay, let's look at the next example. Write the equation of the line with slope 2/5 that passes through negative 3, 4. So let me write that equation for point-slope form again. Y minus y1 equals m times x minus x1. So I've got y minus y1 is 4 equals m 2/5 times x minus x1 is negative 3. Let's rewrite this. Y minus 4 equals 2/5 times x plus 3. Just the double negative again. We'll go ahead and distribute. y minus 4 equals 2/5 x plus 6/5. Once I distribute, 2 times 3 is 6/5. Now we'll go ahead and add 4 to both sides to get y by itself. And we get that y is equal to 2/5 x plus, note real quick that 4 is 20/5. Right, 20 divided by 5 is 4. So I need 20/5 plus 6/5. I need that common denominator there, so 26/5. That's the equation of my line. Okay, next example. If I want to write the equation that passes through 2 points, I need to first find the slope. No matter what formula I'm using to write the equation on the line, I need to know what the slope is. So let's go ahead and find that first. So I'm going to take y2, 7, minus y1, 3, over x2, which is 4, minus x1, which is 2. 7 minus 3 is 4. Over 4 minus 2 is 2. So I get 2. That's my slope. Right? Now the equation of this line will be y minus y1, which is 3, equals m2 times x minus x1, which is 2. Okay, now I used this ordered pair right here for my x1 and y1. As you will find out as you work on these examples, it actually doesn't matter which ordered pair I use in this equation. I could have used this one and I would have gotten the exact same answer. So maybe try that. Try that and see if your answer comes out to be the exact same as mine does. So you will still be using your slope of 2, but you could put a 7 and a 4 here as long as they come from the same ordered pair. Okay, so let me continue simplifying. Okay, that's going to be on this side 2x minus 4, and then we'll add 3 to get a final answer of y equals 2x, negative 4 plus 3 is minus 1. Okay, same thing again right here. I need to write the equation of the line that passes through these points, so I need to start by finding the slope. So the slope is 1 minus negative 3 over 2 minus negative 5. So I get 4 over 7. Okay. So the equation of the line will be y minus, I'm going to go ahead and use this point this time, y minus 1 equals 4/7 times x minus 2. So y minus 1 equals 4/7 x, I distribute, minus 8/7. We're going to add 1 to both sides to get y by itself. We will end up with y equals 4/7 x, and then notice that 1 is the same thing as 7/7. So negative 8/7 plus 7/7 will be negative 1/7. In the next objective, we want to write linear equations that model data and make predictions. So let's look at example 5. The average time Americans spend watching television has increased approximately linearly from 30.9 hours per week in 2002 to 31.7 hours per week in 2004. Okay, so I'm going to write an equation. I want A to be the average time in hours per week that Americans spend watching television in a year that is 2 years since 2000. So what I need to do first is make myself a set of ordered pairs. Okay, and I need to know what the coordinates mean. Now, as we mentioned in one of the previous sections, the order that you put things in ordered pairs is important. So I need to determine if my first ordered pair should be 30.9 comma the 2002 year or the other way around. So which of these is independent is going to go first? Which one will change regardless of any control or anything that we do? That's going to be the time, right? Time just keeps on moving regardless of TV. I mean, TV does not make the years turn. It's definitely the other way around. So the independent variable is time. Independent. And the independent is going to be our x. So when I write my ordered pair right here, I'm going to start with the time value. The next thing to notice is that my time value is supposed to be in years since 2000. So I'm not going to be using the entire 2002 value. I can just put a 2 right there because it's been 2 years since my starting year. So this ordered pair is going to be 2, 30.9. The next ordered pair then would be 4, 31.7. It's very common to use a starting year like 2000 or something similar and have an x value of 2 and 4 versus 2002 and 2004. Imagine graphing that. If you started a graph and you had to go all the way out to 2000 before you could even graph anything, it would be very awkward. So we like to have a starting year and then just be able to graph close to our axes. Okay, let's write the equation of this line. And we know that before I can write an equation, I need to find the slope first. So we're going to start with slope. So we're going to do 31.7 minus 30.9 over 4 minus 2. Okay. So I have 31.7 minus, oops, I keep hitting the wrong button, minus 30.9 is 0.8 divided by 4 minus 2 is 2. 0.8 divided by 2 is 0.4. So my slope is 0.4. Okay. To write the equation, I'm going to start with y minus, pick any ordered pair I want. Let me just go ahead and pick the first one. So I got y minus 30.9 equals 0.4 times x minus 2. And we'll simplify by distributing. Y minus 30.9 equals 0.4 x minus 0.8. Okay. Now I'm going to add 30.9 to both sides. So that'll give us the equation y equals 0.4x plus, so I've got a negative 0.8 plus a 30.9 is 30.1. Okay, so that is my equation. Now, if I go back up and look real quick, they did want me to use different variables for this equation. They said, let's write this equation, but we're going to write it with A being the hours per week and T being the years. I kind of scribbled over that earlier. But I'm just going to change it from X and Y to A and T. So this would be A equals 0.4 T plus 30.1. The variable is the variable that I use is important if I'm going to type the answer into my math lab. They're going to want me to use the correct variables. Okay. What is the slope? What does it mean in this situation? Well, I've already found that the slope is 0.4, but I need to put my labels on here to know what this means. Okay, so this 0.4 was the change in y over the change in x. So that's the change in hours per week over the change in time. Okay, so we increase by 0.4 hours per week each year. So what we're saying here is 0.4 hours per week of an increase in television time each year since 2000. What is the A-intercept? Well, the A-intercept is like the Y-intercept, since I've called it Y instead of A. So that's our 30.1. Remember, the full ordered pair would be 0, 30.1. And what this means is in